Hey everyone, welcome back. This video is going to be about camera manipulations and how we can use the camera locally on the client side. We can use the camera to do like cutscenes, we can make the camera rotate around and all that. For this tutorial, I'll just go over the basics. I'll be doing a little bit of demonstrating with tween service. I'll maybe do interpolates. I probably won't do that though. That's a camera function, but I don't need to worry about that. And yeah, I'll just show you what you need to know before you can actually change the camera or like set the camera C-frame and all that, and what you need to do to reset it. But let's just get straight into it. So under the starter player scripts here, we're going to create a new local script. We're going to call this camera manipulation. And what we need to do is find a way to get our camera. So let's just open up Brave here. I'm going to go to developer.roblox.com and let's just look up camera. Let's see what we can find with that. So we have a class which defines a view of the 3D game world. Let's have a look at that. We've got camera manipulation user interface article. So we can actually start with that and have a look there. So under camera, this actually tells us right here. So in instance of the game, each client has its own camera object associated with it. Camera objects exist only upon the viewer's client, residing in that user's local workspace, and therefore cannot be edited directly from the server. So it's local only. This item is not replicated across Roblox's server client boundary. Each client's particular on that client. Note, workspace.current camera can also be used to find the camera object in Roblox Studio. So we're going to be using workspace.current camera to get our camera. So how does a camera object work? The camera properties define the current view of the 3D game world. The most important of these being the camera's C-frame, so the position and orientation of the camera. The focus represents the point the camera is looking at. It is important this property is set as it also represents where the game thinks you are in the world. Certain visuals will be more detailed and will update more frequently depending on how close you are to the focus. Roblox's default camera scripts take care of this, so we don't need to edit focus. We just need to edit the C-frame. The camera type, so that is read by the game's camera scripts and determines how the camera should be updated each frame. The camera object property is read by the camera script, determines what object the camera should follow. So we can make this follow certain objects if we want. The camera field of view property represents the extent of the observable world visible. So there's a couple things we can look at here. For our case, we're going to be looking at C-frame, camera type, camera subject, and field of view. We won't be looking at focus. So another quick note here is how to work with the camera. Roblox's camera scripts update the camera properties every frame dependent on the current camera type. That means developers looking to control the camera themselves have two options. Setting the camera type property to scriptable, that's what we're going to do. So that means when it is in scriptable mode, the default camera scripts will not update the camera. That is most cases the easiest option. Otherwise, the second method is replacing or modifying the default camera scripts in starter player scripts, and this is only recommended for advanced developers. We don't want to go there. We're just going to do it the simple way of C-frame, camera types, camera subject, and field of view. Let's get started. So to access our camera, it said we need to do so that gives us a camera object, and it tells us we need to change our camera type to scriptable before we can actually edit the camera. Let's do that. Camera.cameraType. So that's an enum equals enum. Oh, that's not enum. That's tweeninfo. Enum.cameraType.scriptable. So now, actually, if we read the description, no default behavior used when developers need to script custom behavior. That's what we're doing. So now that we've done that, we should be able to edit our camera's C-frame. Field of view you can change even if it's not unscriptable, but we want to edit the C-frame, and we want to also edit the camera subject when we come back from the C-frame. So let's just do a test. So if I join the game with this not changing the camera type to scriptable, our camera should work like normal, even though we've got the variable now. So I can move my camera around. It's focusing on my character because the camera subject is the humanoid. So it's focusing on where my humanoid is, which is a character model. But if I suddenly change this to scriptable, let's see what behavior occurs. If I play the game, it looks like nothing happens. What could be the reason behind this? Well, if we look at the camera here, the camera type is still custom. What's happening? As a matter of fact, what's happening is when you respawn, it resets your camera's camera type to custom, and it sets the camera subject and all that back up. So what we need to do actually is on character added, we want to change the camera type. So there's two things we can do. We can do a character added event for the local player, or we can just wait until our character spawns first and then change the camera type, which I think we should do in our testing case. So for now, let's get the local player, game get service players.local player, and let's just do if not local player.character, then, so if our character has not spawned yet, local player.character added colon, we're not going to connect it to a function, we're going to use this wait, yields the current thread until the signal fires, and returns the argument provided by the signal. So pretty much what wait is going to do is say, hey, wait till this event is fired, and then if I have any variables at the left side of this, I've set all the values. So in our case, let's say local A, B, C equals character added wait. Whatever arguments this colon wait returns will go directly to these variables here. So that's called tuples or tuple setting. So this can be one value, that can be a different value, that can be a different one, or they can be nil. I don't know, we've got to print it first, but we don't want to worry about them. We don't care about the character. In our case, this would return the character to the tuple variable, but we don't need the character, we just want to wait for that character to load. But after it's loaded, we want to change the camera type to scriptable. If I try this again, and we have a look under workspace, it did it again, we need to add a wait. Let's add a wait. Task.wait. So when our character adds, it's not fully loaded yet, we're still going to wait for our avatar to load before it actually parents our character to workspace. But now that we added the wait, it will definitely parent it to workspace before our script runs. So this scriptable change here. And because our script doesn't run until after our character is loaded, we override the camera type that is set by the default camera scripts. But now that we've got that, we can see that my camera is locked in place. It's not moving because we're supposed to be scripting ourselves, but my characters can still move around here. So let's do our own custom little script here. Let's do a top-down game. I think that'd be cool. Let's get the run service. So pretty much the run service is, hey, I want to have a connection to the frames. So your game's running frames per second. So if I get the run service, so game get service run service, there's this thing called run service.render steps, which fires every frame prior to the frame being rendered. And what we can do with that is connect that to a function. It has a argument called delta time. We're not going to worry about that, but that is the time difference between the previous frame and the new frame that we're updating with. But we won't need that for this, so I'm going to put that as an underscore, just so you know that there is a argument there, but we're not using it. And what we're going to do is say, hey, current camera.cframe equals cframe.new. What are we going to do with this cframe? So cframe gives you position and it gives you orientation. If I have a look at these little overloading, it's called here, we can see for the third one, we can do cframe.new, a position, and it will automatically make it look at this other position, which is called the look at position. So what I want to do is have this camera go above where the player is. So that's what this position is. And we're going to make it look down towards the player. So that's what we're going to use the look at for. So what we need is the character's current position. So let's do local position equals local player dot character dot primary part. So that would be your humanoid root part dot position. Describes the position of the part in the world. And we're going to do cframe.new position plus vector3.new. So we're going to add a 3D coordinate to it. So we're going to like offset it pretty much. And we're going to say, we're going to move it up 10 studs. So we're going to say position plus vector3.new as the first argument of the C-frame. So that is where our C-frame is located at. That is the origin of the C-frame. We're 10 studs above where the player's humanoid root part is. Now we want to make it look down towards our humanoid root part. So we're going to do comma position. So now we're saying, okay, we want our C-frame position to be above where we are. And we want to make it look down towards where we are. So now it'll be our top-down camera, pretty much. And if we actually just do that, that should be it. We should be 10 studs above where the player is. There we go. So now we are 10 studs above where our player is, and it's top-down. Now this is a little... Go like maybe 20 studs. Okay, that's much better. But let's say people want to customize where their camera or how far their camera is from their character. In this case, I want to scroll. I want to scroll in and I want to scroll out. Let's set up a user input service for this. Now we're starting to add... So right now we're adding components to this. We're going to make the camera move to above our character. But we also want to make it so we can scroll in and out. So we're going to have our run service render steps. We're going to have our camera changing. And now we're also going to have user input. So usually larger games, they've got lots of these. You got different things added together. But really, when you break it down, it's just like a couple things like this added together to create some functional thing. So what we're going to do is have a variable here called height. We're going to set that to 20. In our vector3.new 0, 20, 0, I'm going to change the 20 to our variable height. So now we can change this variable height and we'll move the camera in and out or closer and further away from the character. Now let's set up a user input service event. So let's do local user input service equals game get service user input service. Let's do it below the render steps. Input service to input began connect function. So I did a mistake here. We need input changed actually. And pretty much what we want to do is on mouse scroll or scroll changed or whatever, we'll figure out what the enum is. But only on our scroll changed, we want to check what the position is. Or is it position or delta? It's one of them. We'll have to check which one. But we want to get the +1 or -1. If you're not sure what I'm talking about, check the user input service video. But pretty much when you scroll in or out, under the input changed input object, either position or delta, one of the two, the X changes to +1 or -1. So I believe scrolling in is -1 and then scrolling out is +1. So we can use that to our advantage to make this height value change. So what we'll do is input change. We get a input object and game processed event boolean. Let's just do that. Input object was processed. So in our case, we're not going to use was processed. We're just going to use the input object. We're going to say if input object dot user input type is equal to enum dot user input type dot, and I said scroll. So we're looking for mouse wheel. So the mouse's wheel. Then, so only when we're scrolling our wheel up and down, or we're pressing the wheel, and I don't know if that will show up here. No, it wouldn't, because that's input began. So input change is when our scroll wheel changes. We want to do, let's just print input object dots. No, it's not position. Would it be delta? Let's try delta first. I believe it should be delta. So if I scroll in, scroll out, okay, it's not delta. Is it position? I don't remember. Scroll in, scroll out. Yeah, so in our position value, we can see that we've got +1 and -1. So if I scroll out, it's -1. If I scroll in, it's 1. So what we actually want to do is get the z value. So that's what that third value is. So we've got an x, y, and z. We're going to get z, which is a scroll in or out. And let's just print that by itself now. So that should give us a clear understanding of what we're doing. So if I scroll in, it's 1. If I scroll out, it's -1. In our case, we want to flip this number. We're going to say negative the position z, because we want scrolling out. So when you scroll out, it should zoom your camera out. And when you scroll in, it should zoom your camera in. So when we're zooming in, we want to minus a number from height. When we're scrolling out, we want to add numbers to height, so that our height gets bigger or smaller, depending on if we're zooming in or not. And then all we have to do is just height plus equals the negative of the position z from the user, or from the input object. There's one problem though, which I'll show in a second, and that is that we can zoom in really far and we can zoom in really out. We want to make it so that there is a limit. And as you can see, it broke. Line 18. That was interesting. But yeah, we want to have max and min amount that we can zoom in and out. So let's do that. Let's do it the easy way. We'll do height plus equals the negative, input object position to z. So we zoom in or out. Then we will also do height equals math.clamp. So this will do returns a number between min and max. So if we put height as the value we want to clamp, and let's say the minimum is 20, the maximum is 30. What that's going to do is say, hey, if height is smaller than 20, make it 20. Otherwise, if height is larger than 30, make it 30. So that way, we're always between 20 and we're always between 20 and 30. We're never below 20, we're never above 30. And what we should probably do is actually do it like that. 20, 30, 20, 30. So let's merge it into one line. So we've got height equals math.clamp. The first value is height minus input object position.z. Second argument for the math.clamp is 20. Third argument is 30. So we'll never go below 20 or above 30 for the height. And that's pretty much it. If I just play the game and we try zoom in or out. Also, I'm not sure why my avatar died. That was a weird bug. But if I try zoom in, nothing's happening. If I zoom out, I can zoom out, but not very far. If I try zoom in, you can start to understand that there's a limit on what the zoom can be. But yeah, so now that we've got that, we're stuck with our camera here. I'm not totally sure why that's happening. That's a really weird bug. But as you can see, that is working, and yeah. Hopefully, you got that in your head, that you can edit the camera here. Maybe this was a little bit too much for some of you. I don't know. Maybe play around with it, understand what different pieces do. Or rewatch the video in some cases, that can help. Yeah, it is weird. Oh, you know what? It's probably supposed to be... It's probably meant to be heartbeat. Or pre-render. Let me try and jump again. So that's fine if I jump. Yeah, okay, so... Oh no, it did again. That is really weird. What? simulation. Let's try that. Oh yeah, I totally forgot they're not enabled. Oh yeah, whatever. That's weird. Hopefully it doesn't do that for you. I'm not completely sure why it's doing it for me, but yeah. Hopefully you learn a little bit of camera manipulation here. So pretty much it's just you need to change the camera type to scriptable, and then you can set the C-frame in a loop or whatever. Next thing I want to look at is the, let me get rid of these real quick. So what we want to look at next is the camera subject. So if I put a part in here, I'm going to set the camera subject to this part. The camera subject here says instance question mark. So that's pretty much the humanoid or base part. So in our case, this part here is a base part. That is the camera's subject. So let's just see what happens when I set this part as the camera's subject. So what is it meant to be looking upon? And there we go. So instead of my character now, it's focusing around this part here. And I'm kind of stuck here. I can't do much. And if you want to, let's say, if you want to reset the camera back to the humanoid, you can either actually just delete the part, which I can't in this case, but scripting-wise you can. Otherwise, set it to the humanoid of the avatar. You can actually set it to the head too if you want. Although it looks a little bit funky. Humanoid root part's also another stable one. But definitely the humanoid's probably better. But yeah, camera subject is just pretty much what you're focusing on. What was the other one? There was another thing. Camera subject, field of view. The field of view we can actually do without this. Let's get rid of these. But we can pretty much just say, so we have a look at the camera here. Our current field of view is 70. If I start changing this in Studio, you can see I zoomed in here. But it's pretty much how much of the game you can see angle-wise. And it will spread across your entire screen. But yeah, that's like 120 degrees, so 60 degrees either way of the direction you're looking. That's 35 degrees of either way of where you're looking. But you get the general idea. And you can set that via script, like just setting a number here. Let's do some tweening. And then I reckon that'll be it. There is some other properties here, like viewport size. That's pretty much your window size for your camera. And yeah. Also, another important one is the screen point to ray. That's how that ray casting with touch tap in world is done. You have the mouse position X, mouse position Y, or touch position X, touch position Y. You don't need to specify the depths, but you can. And it will create a unit ray from the position on the screen. Like that. So, we won't worry about that now though. You can look at the other thing there. But pretty much what we want to do is, I just want to test the, what was it? I've forgotten. Oh, we want to tween. That's right. So, for now, let's just say, let's actually do something crazy here. In our command bar, I'm going to do instance.new part, comma, workspace, dot cframe equals workspace dot current camera dot cframe. So pretty much what this is doing is it's going to create a part, parent it to workspace, then set the C-frame of that part to my camera's C-frame. So I press enter, our part's here, but it's actually where my camera's at. So I'm going to name that one 1. I'm going to name that one 2. I'm going to name that one 3. And let's make this local script here. Let's do local player equals game get service players dot local player. If not, local player dot character, then local player dot character added wait. And then we need the task dot wait. And then what I'm going to do is set the camera type to scriptable like we did before. And I'm going to get tween service this time. And then I'm going to make a table of these parts. So I'm going to have to use square brackets here because you can't index with numbers. So here we've got 3 parts inside this table. We're going to loop through this table and we're going to tween from our current camera position to this part. We're going to wait for that tween to finish, then tween to the next one, and then tween to the next one after that in the same order of fashion. So to start, let's do for underscore. We don't need the index for this. For underscore base part in I pairs. Parts do. And I'm going to say local tween equals tween service colon create. So I'm going to create a new tween for the camera. So my camera. For tween info, I'm just going to do tween info.new2. So that's going to say this tween. So to get from the current position to the goal, I want it to take 2 seconds. And then we need to make this goal table pretty much a dictionary of the property values which we want it to finish with. So in our case, we want the C frame to be the base part.C frame. So we want to go where this base part is. We want to play the tween, and I want to do tween.completed wait. I should probably be doing this here. I should probably teach you tween service later on, but I'm going to teach it to you now anyways. So this is saying for every part that we've got inside this table, create a tween stating that we want to tween our camera, so where we are right now in the world with our camera, we want to tween it to the base part C frame. So we want it to slowly animate, or slowly, however long this takes, we want to animate it going to the base part C frame. So the base part C frame defines that we go to that position, but we also rotate to look where that part is also looking. We'll see this in a minute. But what should happen is we should go looking, so looking down this way. We should go up here. We should be looking that way. And then up here, we should be looking it down that way. So when I say we want to end with the tween info or the goal C frame, you know, all that, I want it to be looking at. Oh, actually, I forgot to anchor them. Let me anchor them. So pretty much, I want to tween my camera so it goes where those parts are, where they're looking, where they're positioned at. So you can see I'm looking where the parts are looking, but I'm also going to the position where the parts are at. And then we can have it just we can do one final tween, which will be let's actually get an origin. Local origin C frame equals workspace or current camera to C frame. And then we're going to go back to that origin C frame. And we're just going to reset this to custom. So if you set the camera type to custom, it will just go back to using the camera subject or whatever's set. So if I try that, we should twin to those 3 parts like that. So I should be able to jump in all that. And then it will bring our camera back towards where we are. And then it will reset the camera because we set the camera type back to custom. And hopefully you understood some of this. If you don't understand the tween service, don't worry about it. I'll do a video later on that will describe and go through using tween service, how it works and all that. But for now, this was mainly about camera manipulation. So changing the camera, setting the C frame, tweening it, you know, all the properties. And hopefully you learned something. Hopefully it's useful for you. But I will see you in the next video, which is pathfinding, which is going to be great fun. So I will see you then.